Hello, my name is Michael De Silva and I'm a VR developer and I'm working on some software products for the HTC Vive. So this is a demonstration scene that I've created in very high fidelity. I'll just show you VR. So basically this is Lighthouse technology which tracks the movement of my hands and also my headset. So my head basically in 6 degrees of freedom, so I can move up, down, left, right, and this all tracks on my head motion device, head mounted device. So in virtual reality, basically you really get a sense of scale, and I'm just going to demonstrate over here. You should be able to see the lighting that this captures. It's all dynamically generated, and obviously we can pick up objects, we can look at them, you get a real sense of presence being in virtual reality. This is all in stereoscopic vision, which is fantastic. It looks unbelievably realistic. I'm just going to throw this away. VR, you can always give yourself super strength, which is great. So here we can sort of just go through a couple of things in this demonstration scene. Obviously you can see the texture of the timber. I've got a real sense of scale of how big this tree is. Just looking at that, how wide it is. I can almost put my arms around it. It's fantastic. I can look at all these rocks, just the texturing on them, just the moss, the grass, all the flowers. This is all generated in stereoscopic 3 dimensions. So I can almost look at this flower. Again, you can obviously pick up objects. You can do all sorts of stuff. This is a very high fidelity scene with a lot of texturing and a lot of work that sort of went into this. And I'll just demonstrate some other applications. This obviously would be a fantastic application for experience-driven virtual reality technology, where you can actually travel to a location and experience it as if you're there. So obviously in room scale, I can move around the confines of my room with the Lighthouse trackers. And this is, I've also given myself a couple of buttons over here, which actually give me motion beyond regular movement. So I can basically fly through space at a control speed. We'll go to another demonstration scene to look at some other applications beyond this high fidelity sort of experience. So this is a construction scene, and one thing in construction is the understanding of drawings and understanding of how the project's going to be built. It's very hard to visualize just looking at drawings and plans. With the VR technology, the fantastic thing is anyone can look at all this and look at how a project is going to be built even before the first pile has been driven, before all the site has been set up. So this is a great tool for planning, for stakeholder buy-in, for training, for risk assessment, for evaluating construction methodologies and tossing up between one and the other, because you can essentially walk through the site at any stage of construction and basically have a think about what you really want to do and what you need to achieve. And the fantastic thing about this is anyone can go in and it feels entirely natural. I can sort of move around the space. I can look around these columns. I can sort of walk into the basement, get a sense of scale. And the thing about this is we can animate anything in this space. We can animate this excavator. We can animate that crane over there. We can put stage construction sequences. We can animate the concrete pour. We can animate the whole structure going up in the time-lapse sort of scenario, and all this in virtual reality, where you have the capability to sort of look around and move around in this video. That's a fantastic technology. I can't sort of emphasize that enough. I've demonstrated to so many people, and everyone's saying this is completely unreal. It's amazing. So now this is another scene that we have generated, and I've put in some elements so we can muck around. Obviously this is it looks like a wharf. We have a wharf crane, a gantry crane over here, and the amazing thing about VR is you can animate anything and you can sort of see how things look like without actually being there. So here's an example of animation sequence. The crane's moving across, it's dropping a container in slow motion. We can obviously reverse that. I've put controls in my controller to be able to move things around. So it's great fun sort of being here. You can move around, you can view that movement from any angle you want. So this is impossible in real life, obviously, but in VR, nothing is impossible. That's the amazing thing about this technology. So looking at that, see, you can do an amazing amount of analysis and planning, and you can demonstrate to people what you want to achieve. So over here, another example, we can sort of, work out our site layouts and traffic control measures, and you can sort of say, no, I don't really want this here, I want this over there, I want to move this around. I'm just having a bit of fun throwing stuff around, but obviously you sort of get what I mean. We can move and we can decide, I want to put this over here. Or we can say, I don't really want this concrete barrier here, I'm just going to punch it, move it across. It's unbelievable, this technology. Obviously I'm as strong as the Hulk right now, so that's why I'm punching concrete barriers around. So over here we've got the, it's a basic chainsaw, and another application of VR is you can talk about training of crew and personnel, and you can sort of put them in environments that they usually would not be in. And the amazing thing is this could be anything. It could be a drill, or it could be a welder, and you can actually program it so that you can actually do different things. That you could program this so that it could actually be like a real chainsaw. Obviously, I haven't really done that. It's just a model at the moment, but you can do so much training with this. You can put people in environments that they normally wouldn't be in, and you can sort of do assessments on all that. So we'll go under the wharf, and the thing about this is you can sort of see, I spent a bit of time in the water, so I'm pretty proud about that. Going underneath, you can see the dynamics of the lighting. We can change the lighting settings so you can be, it looks like it's about dusk now. You can sort of make it twilight, you can make it midday, and you can do assessments of what the lighting conditions will be. And being underneath here, you really get a sense of presence of the confines of this scenario. You can sort of see over here, I'm just underneath now. It almost feels like I'm going to bump my head on this concrete beam. And you can see the piles in here, they're at 6 meter centers. So I can almost feel like, yeah, that feels like 6 meters away. Just sort of trying to stretch my hand out across there. It feels like 6 meters, and it is 6 meters because it's all life size, life scale. So over here you can obviously imagine we can do assessments of egress of crew, different training, how we're gonna, maybe if we're gonna be installing or repairing the concrete underneath a wharf, how are we gonna do the platforms, the staging, the access egress for repair crews, personnel, anything in, even diving work. You can sort of start planning how you want to do your diving work, and you can start simulating. That's the amazing thing about this technology. The simulation that it can achieve, it's unprecedented. So over here I've got a crane, which on a barge, which is something that I knocked out in about 20 minutes. So please give me some slack. It's not very well done, but it's gonna give you a demonstration of some crane activities and lifts that we can do. All this can be modeled, so you can even model the barge behavior with the crane lifts and all that. So anything is possible. So over here we've got a simple crane lift. It's pick up a pile and it's chucked it into the water. It's a very quick animation that I made just to demonstrate some of the potential use cases. We can do crane lifts. We can sort of assess the barge stability, the impact of the wake from from passing ships on the water. So it's all done in a physics engine. So all of this is possible. It's just a matter of setting the parameters for it to sort of operate around. over here you've obviously got the boulders in the water, which show, again, I'm quite pleased with the refraction that I'm catching from the water shader that I've installed. So, and we're back to the high resolution forest scene. So I'm just gonna cut the video right here, as we are pretty much returning to the start point. So I hope you've enjoyed this short blurb of potential use cases in the industry, and I will see you in the next video. Thank you.